Sci Sippers, prepare to have your minds blown. Today's Sci Sips Binge Bonanza is a celestial cocktail of mind-bending science served in a 1-hour scientific spectacle. We'll be gazing up at the awe-inspiring phenomenon of eclipses, diving deep into the controversial world of fracking, and venturing to the farthest reaches of the cosmos with the Voyager probes. First, get ready to witness the celestial dance of the Enigma of Eclipses. We'll delve into the science behind these breathtaking events, where the sun, moon, and earth align to create a celestial spectacle. From the complete darkness of a total solar eclipse to the dramatic ring of fire in an annular eclipse, we'll explore the different types of eclipses and the upcoming celestial event you won't want to miss. Next, we're heading underground to explore the enigmatic depths of petroleum extraction fracking. This controversial technique unlocks vast oil and gas reserves, but also raises concerns about environmental impact. We'll dissect the science behind fracking, explore its economic benefits and environmental drawbacks, and help you form your own informed opinion on this complex energy issue. Buckle up, animal lovers, because we're going on a bizarre birdwatching expedition. Prepare to meet Attenborough's strange bird, the Imparavis. This feathered enigma from the dinosaur era defies categorization with its unique anatomical features. We'll explore the mysteries surrounding this bizarre creature and delve into the fascinating world of paleontology. Feeling adventurous? We're setting our sights on the farthest reaches of the solar system with the Voyager space probes. Launched in 1977, these twin spacecraft have ventured beyond the boundaries of our solar system, sending back groundbreaking data and captivating images. We'll explore the incredible journey of the Voyagers, the mind-blowing discoveries they've made, and the mysteries they continue to unveil about the cosmos. Our planet is a dynamic place, and deep within its crust, a new chapter is unfolding. We'll witness the birth of a new ocean, the sixth, Africa's tectonic tale. The Great Rift Valley in Africa is slowly tearing the continent apart, creating a new ocean basin. We'll explore the power of plate tectonics, the dramatic geological changes shaping our planet, and the potential impact of this new ocean on Earth's future. From ancient fire mirrors to powering our modern world, we'll explore the fascinating journey of solar energy, from ancient warfare to modern marvels. Sunlight has been harnessed for millennia, and now, with advancements in solar panel technology, it's becoming a key player in the fight against climate change. We'll explore the science behind solar energy, its growing importance, and the exciting future of this renewable resource. Finally, we're venturing into the realm of the unknown black holes in the lab, unraveling the mystery. Can we recreate these mind-bending cosmic giants here on Earth? Scientists are conducting mind-boggling experiments to understand the nature of black holes. We'll explore the latest research, the challenges of simulating these cosmic powerhouses, and what these experiments could reveal about the fabric of space-time itself. Hit that play button, grab your favorite beverage, and maybe a notebook to jot down all the mind-blowing facts, and let the scientific exploration begin. Don't forget to like, comment, and subscribe for more Sci Sips shenanigans. Remember, science is a thrilling adventure, and this binge watch is your ticket to the front row. So buckle up and let's dive in.
In the grand theater of the cosmos, few spectacles rival the majesty of a total solar eclipse. Here, the celestial bodies align in an exquisite ballet of shadows and light, casting our world into an ethereal twilight. Have you ever witnessed a solar eclipse? The world plunged into darkness, an unnatural chill in the air. It's a sight that has captivated humanity for millennia. But what if I told you eclipses are more than just a cosmic light show? They're celestial omens, powerful forces that can influence our lives in profound ways. From the ancient wisdom of India to the whispers of the tarot deck, join me as we unlock the secrets of solar eclipses and their astrological significance. The upcoming solar eclipse, scheduled for April 8th, 2024, promises to be such an event. A rare cosmic alignment that will be visible from specific regions in North America. This celestial phenomenon occurs when the moon, in its orbital journey, positions itself between the Earth and the Sun, casting a shadow upon our planet. However, total solar eclipses are a rarity, demanding precise alignment, specific viewing locations, and fleeting durations. This particular eclipse will trace a path of totality, a slender strip of shadow that spans 10,000 miles, yet is only 115 miles wide. It will journey from the northwestern territories of Mexico, cross the United States, and culminate in the southeastern regions of Canada. This path of totality, as it is known, is the only location where one can fully experience the breathtaking spectacle of the total solar eclipse. The path will cover 15 states in the United States, with approximately 31 million people residing within its reach. Yet, as the humorous yet informative map of Nope, created by eclipse cartographer Michael Zeiler emphasizes, being close to the path of totality does not guarantee a front row seat to the total eclipse. Weather too plays a crucial role in the viewing experience. While southwestern regions are more likely to have clear skies, there is no guarantee of cloudless weather anywhere along the path. Historical cloud coverage data suggests a 50% chance of mostly clear or better skies from Mazatlan, Mexico, to Little Rock, Arkansas. Yet even under less than ideal conditions, the eclipse remains a sight to behold, with the phenomenon of eclipse cooling potentially causing clouds to dissipate, offering a clearer view. While some cultures offered sacrifices during eclipses, the extent of these practices and the level of violence involved can be debated. Archaeological evidence suggests some sacrifices might have been symbolic rather than literal offerings. Let's look at 7 ancient cultures that had religious beliefs around eclipses. Incas, South America. The Incas believed the sun god Inti was angry during eclipses. They would respond with loud noises and sacrifices of llamas or even children, though some accounts suggest these sacrifices were symbolic rather than literal. Norse, Scandinavia. In Norse mythology, a giant wolf named Skoll chased the sun and moon. Eclipses were seen as Skoll nearly catching its prey. To scare the wolf away, the Norse would bang pots and pans, creating a thunderous sound. China, East Asia. The Chinese believed a celestial dragon devoured the sun or moon during eclipses. To appease the dragon, they would beat drums and clash cymbals, hoping to frighten it away. Ancient Greeks, Europe. The Greeks had various myths regarding eclipses. Some believed a giant hand or mythical creature covered the sun. Sacrifices of animals like black sheep were offered to appease these unseen forces. Aztecs, Mesoamerica. The Aztecs viewed eclipses as a battle between the sun god Huitzilopochtli and the moon goddess Coyolxauhqui. They believed the world would be plunged into darkness if Huitzilopochtli lost. Human sacrifices were offered to strengthen the sun god. Ancient Egyptians, North Africa. The Egyptians believed the sun god Ra was battling a giant serpent named Apophis during eclipses. They would chant and make offerings to ensure Ra emerged victorious. While some historical accounts mention human sacrifice, evidence suggests these were symbolic rituals. Babylonians, Mesopotamia. The Babylonians saw eclipses as bad omens, often signifying the death of a king or other important figure. They would attempt to predict eclipses through astronomical observations and use rituals to avert potential disasters. While there's limited evidence of gory practices, some sources mention animal sacrifices during eclipses. Eclipses, while awe-inspiring, haven't directly provided physical benefits to humans. However, they've played a surprisingly positive role in our history in a few ways. Eclipses were celestial mysteries that couldn't be explained by everyday observations. Witnessing them likely piqued the curiosity of early humans, pushing them to question and seek explanations for natural phenomena. This curiosity is considered a major driver of scientific progress. Eclipses provided opportunities for early astronomers to gather valuable data. By observing how the Earth's shadow fell on the moon during a lunar eclipse, ancient Greeks like Aristarchus were able to determine the spherical shape of Earth and even estimate its size. Similarly, solar eclipses allowed them to study the sun's corona, which is usually hidden by the sun's bright light. Eclipses are rare occurrences that bring people together. The shared experience of witnessing this celestial spectacle can foster a sense of wonder and community, even across cultures. Historical accounts mention warring factions laying down arms to observe a solar eclipse, highlighting its potential to bring a temporary truce. The need to predict eclipses accurately spurred the development of calendars and astronomical tools. This focus on celestial movements contributed to advancements in mathematics, physics, and navigation, all of which have broader applications. Sci Sips is a channel dedicated to science, but our story would be incomplete without also considering astrology. From ancient China and India, astrology has been the mainstay of legends. In astrology, across cultures, eclipses can mark the culmination of old situations and the initiation of new chapters. This could involve relationships, careers, or personal growth journeys. They may also bring hidden issues or emotions to the surface, prompting us to confront them and move forward with clarity. Some astrologers see eclipses as nudges towards our destined path, accelerating changes that are ultimately for our highest good. Vedic astrology, India. Eclipses are associated with the shadow planets Rahu and Ketu, often seen as disruptive forces. A solar eclipse, particularly in a sensitive zodiac sign, can signify sudden changes, challenges, or revelations. Vedic astrology emphasizes the importance of following specific rituals and avoiding negative activities during the eclipse period to minimize disruptions. East Asian astrology, China. Eclipses are viewed as imbalances between celestial bodies, often involving the sun and a mythical dragon. They can represent disruptions in leadership, authority figures, or societal structures. Practices involve creating loud noises to scare away the dragon and restore balance, ensuring harmony is restored. Western astrology, horoscopes and tarot. Solar eclipses are seen as new moons on steroids, intensifying the themes associated with new beginnings, endings, and significant shifts. The specific zodiac sign where the eclipse occurs influences the life areas most likely to experience change. Tarot cards associated with new beginnings, the Fool, the Magician, or transformation, the Tower, Death, may resonate with the eclipse energy. To summarize, a total solar eclipse is a rare and awe-inspiring event, a testament to the grandeur of our cosmos. The upcoming eclipse on April 8, 2024, will trace a path of totality from northwest Mexico to southeast Canada, offering those within its narrow strip a breathtaking spectacle. Weather conditions will play a significant role in visibility, with southwestern regions likely to have clearer skies. Yet, regardless of conditions, the eclipse remains a captivating experience that underscores the celestial ballet that continually unfolds above us. Remember, the cosmos is not just above us, it is a part of us, and events like a solar eclipse offer a humbling reminder of our place within this grand tapestry of existence. We hurtled through the cosmos today, exploring the wild world of solar eclipses and their astrological influence. Did your zodiac sign get a cosmic nudge, spill the tea, or space dust in the comments below? If this video left you starstruck or just curious, don't forget to smash that like button and subscribe to Sci Sips for more stellar content. The universe is vast and full of mysteries, and we're here to explore them all with you. So buckle up, space cadets, because our next cosmic adventure is just beginning.
Ever felt like there's a hidden treasure chest buried deep beneath our feet? Well, there kinda is. It's full of oil and gas, and to get to it, we use a technique so powerful, it can crack rocks. That's right, folks. Today we're diving into the world of fracking. Imagine a process so powerful, it cracks the Earth's deepest layers, unlocking energy that fuels our civilization. Welcome to the fascinating world of fracking, a technique that has revolutionized the energy sector, yet remains shrouded in mystery and controversy. Fracking, or hydraulic fracturing, is a procedure that involves injecting a cocktail of water, sand, and chemicals into deep rock formations with an intensity that would make even the Earth's most formidable forces take notice. This high-pressure concoction fractures the rock, freeing natural gas and oil trapped within its confines and making it accessible for our ever-hungry energy needs. But the power of fracking extends beyond its ability to crack open the Earth. Its influence permeates our society, our economy, and our environment. It's a process that has breathed new life into regions rich in shale gas and oil, creating jobs, boosting economies, and shifting geopolitical power dynamics. Yet, the exact impact of fracking on our environment remains an enigma. It's akin to a geological jigsaw puzzle, with pieces scattered across a spectrum of scientific disciplines. from the potential for induced seismic activity to the contamination of ground and surface water. The environmental footprint of fracking is a hotbed of debate and a subject of ongoing research. The labyrinthine complexity of fracking's environmental impact, coupled with the cloak and dagger secrecy often surrounding the exact chemical compositions used, adds to the mystique of this process. It's a subject that continues to baffle, fascinate, and even alarm us. For some, fracking is a lifeline, a bridge to a future where renewable energy reigns supreme. For others, it's a Pandora's box, unleashing a slew of environmental challenges we're ill-equipped to handle. We're on a quest to unravel these mysteries, to shine a light on the dark corners of fracking, and to understand the full breadth and depth of its influence. For as we journey into the future, the path we tread will undoubtedly be shaped by this potent and enigmatic process. Fracking, a process as enigmatic as it is influential, continues to baffle and fascinate us. Fracking isn't just about injecting fluids into the ground. It's a symphony of engineering, geology, and chemistry, all playing together in perfect harmony. At the heart of this symphony is the construction of the well. Engineers and geologists must collaborate closely to design a well that can withstand the high pressures and temperatures of the subsurface. The well bore, the hole drilled into the ground, is lined with a steel casing providing structural integrity. Cement is then pumped around the casing, forming a barrier to prevent any leakage of fracking fluids or gas into the surrounding environment. A key player in this symphony is the proppant, tiny solid particles, often sand or ceramic, that are mixed with the fracking fluid. When the fluid is pumped into the well, the pressure causes the rock to fracture, creating pathways for the gas to flow. As the pressure is released, these fractures would naturally close up again, but the proppant holds them open, allowing the gas to continue to flow. And let's not overlook the role of horizontal drilling. By drilling vertically until they reach the desired depth, and then turning and drilling horizontally, engineers can increase the contact area with the reservoir, accessing more gas with fewer wells. This technique also enables them to reach deposits that would be unfeasible to access with a traditional vertical well. But in all of this technical precision, there is an element of mystery. The composition of the fracking fluid, a blend of water, proppants, and various chemical additives, is often a closely guarded secret in the industry. Each company has its own unique recipe, tailored to the specific conditions of each well. These additives can include everything from friction reducers to biocides, all designed to enhance the efficiency of the process. In its complexity and precision, fracking truly is a marvel of modern engineering. The blend of disciplines, the intricacy of the techniques used, and the mystery surrounding the fracking fluid composition all contribute to the fascinating enigma that is fracking. It's not just about breaking rocks. It's about unlocking the potential that lies beneath our feet. For all its brilliance, fracking is not without its shadows. It stands at the heart of several controversies and unanswered questions. As we navigate the labyrinth of fracking, we encounter potential hazards cloaked in the guise of progress. The specter of environmental impact looms large. Water contamination is a fear that pertains, with fracking fluids potentially infiltrating our groundwater, bearing a toxic cocktail of chemicals. The industry argues that the risk is negligible, the protocols in place stringent. Yet, skeptics persist, pointing to instances of chemical leaks and spills as evidence of potential catastrophe. Then, there is the issue of induced seismicity. Fracking, by its very nature, involves fracturing the Earth's crust. But could this trigger earthquakes? Some studies suggest a correlation, yet others refute it. The scientific community is caught in a whirlwind of debate, with consensus remaining elusive. The ground beneath our feet, it seems, is not just being fractured physically, but metaphorically as well. This only underscores the need for transparency and further research. The industry has been accused of cloaking its operations in a shroud of secrecy, with the exact composition of fracking fluids often kept under wraps. This lack of transparency fuels speculation and mistrust. Only through open discourse and rigorous scientific investigation can we hope to shine a light on these shadows. Moreover, the industry must actively engage with the scientific community and the public alike. It must be willing to address concerns, to acknowledge uncertainties, and to invest in research that can help mitigate potential risks. The future of fracking is not just about harnessing the Earth's hidden treasures. It's about doing so responsibly. The journey of fracking is akin to a high-stakes game of chess. Each move is calculated, each decision fraught with potential repercussions. The question is, how do we balance the pursuit of energy with the preservation of our environment? As we delve deeper into the unknowns of fracking, we tread on the thin line between energy necessity and environmental responsibility. As we stand at the crossroads of energy and environmentalism, the future of fracking hangs in the balance. The unfolding tableau of the future is both promising and precarious. With advancements in technology, fracking could evolve into a cleaner, safer method of petroleum extraction. Innovations such as low-frequency seismic imaging and fluid recycling can potentially minimize environmental impact while maximizing yield. However, the future isn't just about technological leaps. The tides of energy demand are shifting. As the world grows increasingly thirsty for power, can fracking quench this insatiable thirst? Or will the surge in renewable energy usurp the throne, casting a shadow over the future of fracking? Environmental consciousness, too, is etching its mark on the landscape of the future. With a global populace increasingly aware and alarmed about climate change, the acceptance of fracking is likely to be a field of contention. In the grand scheme of energy production, fracking remains an enigma, its future as uncertain and intriguing as its present. Did that frack you up? Smash that like button. Subscribe to Sci Sips for more mind-blowing science. Feeling pumped about fracking? Let me know in the comments. You've been fracktastic. Like this video and subscribe to Sci Sips for more scientific shenanigans.
Alright Sci Sippers, before you go hurtling back into the real world after this epic scientific odyssey, I want to take a quick moment to chat. Building this channel, bringing you these videos, and exploring the wonders of science with all of you is a blast. But to keep the scientific adventure going strong, your help is essential. Liking this video lets YouTube know you enjoyed it, which helps the algorithm share it with more curious minds like yours. Subscribing to the channel ensures you never miss a future science bonanza and lets you know when we upload new content. But the real magic happens in the comments. Leaving a comment, whether it's a question you have, a mind-blown reaction, or even a suggestion for a future topic, is like rocket fuel for the channel. It helps us understand what excites you and allows us to create even better videos that cater to your scientific interests. So, smash that like button, subscribe for more, and leave a comment below, letting us know what you thought of this wild ride through science. Thanks for joining the Sci Sips fam, and until next time, stay curious.
Forget everything you thought you knew about birds. Imagine a creature with feathers, wings, but no teeth. This isn't some mutant escapee from a sci-fi movie. This is Attenborough's strange bird, a real-life fossil discovery that's rewriting the history of evolution. Join us as we dive into the life and times of this feathered enigma and uncover the secrets it holds about the rise of modern birds. We'll be cracking the code on its toothless beak, its place in a lost world of dinosaurs, and why it might hold the key to understanding why some birds soared to success, while others became relics of the past. Buckle up, because this is one strange bird that's about to take flight. The Enigma of Imparavis attenboroughi, or Attenborough's strange bird as it's often called, lies in its unique features. This ancient bird hails from a group known as Enantiornithinus, a lineage that coexisted with dinosaurs. And yet, unlike its contemporaries, this bird was toothless. This peculiarity is a clear deviation from the norm.
as it was previously believed that the evolution of toothlessness in birds occurred much later in history. This discovery pushes back the timeline by nearly 50 million years, offering a new perspective on the early evolution of toothlessness in birds. But the mysteries of Imparavis attenboroughi go beyond its lack of teeth. The bird's fossilized forelimbs indicate a strong wing power, a feature that is not common among modern birds. This suggests that Imparavis attenboroughi likely foraged on the forest floor for fruits, seeds, or insects, painting a vivid picture of its behavior and ecology. This discovery has been made possible through the collaborative efforts of researchers from around the globe. It underscores the importance of understanding ancient biodiversity in addressing current conservation challenges. It also emphasizes the interconnectedness of all life forms and the urgent need to preserve Earth's biodiversity. In summary, the discovery of Imparavis attenboroughi brings to light new insights into avian evolution. It challenges previous beliefs about the timeline of toothlessness in birds, highlights the complexity of bird history, and underscores the importance of global scientific collaboration. This bird, named in tribute to Sir David Attenborough, serves as a poignant reminder of the intricate and ever-evolving tapestry of life on Earth. While Imparavis attenboroughi lacked teeth, its beak might have offered advantages over its toothy brethren. Maybe the beak was lighter, allowing for stronger flight muscles. Perhaps it facilitated a wider variety of diets, including seeds and fruits not accessible to toothed birds. The toothless beak, a hallmark of modern birds, also evolved independently in some dinosaurs like the theropods, ancestors of birds. Enantiornithines, the group Imparavis attenboroughi belonged to, were incredibly diverse. This highlights the lost world these birds inhabited alongside dinosaurs. We can't delve into Attenborough's strange bird without exploring the fascinating world of beaks. Modern birds boast an incredible variety of beak shapes, each with a unique function. From the massive toucan's fruit-crushing beak to the hummingbird's specialized nectar-sipping straw, these structures are crucial for a bird's diet and lifestyle. Now, let's shift gears and explore the mystery surrounding the demise of the Enantiornithines, the group Imparavis attenboroughi belonged to. Did competition with the ancestors of modern birds play a role? Perhaps they occupied similar ecological niches, leading to one group outcompeting the other for resources after the mass extinction event. We can then discuss how the ancestors of modern birds might have possessed unique adaptations, special diets, nesting behaviors, or even superior flight that allowed them to weather the KPG extinction storm. As we continue to unearth the secrets of our planet's past, we are reminded that every discovery, every piece of the puzzle, brings us closer to understanding the intricate web of life that connects us all. And in the words of Sir David Attenborough himself, it is that understanding of the natural world that will be the salvation of the human race. Blown away by Attenborough's strange bird, there's more where that came from. Smash that like button and subscribe to Sci Sips for mind-bending science content every week.
Buckle up, space explorers. Ever wondered what's beyond our solar system? Forget the edge of the world myths. We're hurtling through a cosmic ocean with a message in a bottle, a message riding on two daring spaceships called Voyager 1 and 2. Launched in 1977, these probes have defied expectations, becoming the farthest human-made objects ever and the first to enter interstellar space. They carry a golden record, a kind of cosmic calling card with greetings, music, and even natural sounds like whale calls. So join us as we blast off on a journey to explore these incredible spacefaring pioneers, the Voyagers. In the vast expanse of interstellar space, a voice from the past whispers, Voyager 1. The pioneer of cosmic exploration, now over 15 billion miles from Earth, recently fell silent. It started speaking in a language we couldn't comprehend. Not an alien dialect, but a garble of unintelligible signals, the result of a suspected cosmic particle impact. Since November of 2023, the spacecraft's Flight Data Subsystem, or FDS, has been transmitting these enigmatic signals. A computer glitch? Or something more sinister? The FDS, the brain of the spacecraft, had somehow malfunctioned, transforming its data transmissions into indecipherable gibberish. But the team at NASA's Jet Propulsion Laboratory didn't falter. They rolled up their sleeves and got to work. Through a series of strategic commands, they poked and prodded the distant Voyager 1. On March 1, 2024, a command was issued that led to a significant breakthrough. Voyager 1 responded, sending back a complete readout of its memory. The garbled messages turned into a trove of valuable insights, a glimpse into the workings of a spacecraft operating in the harsh conditions of interstellar space. Decoding the outlier signal from the FDS was akin to finding a needle in a cosmic haystack. The engineers compared this signal with previous data, seeking discrepancies in the code, variables that could pinpoint the source of the problem. Their efforts are a testament to human ingenuity, a testament to our relentless pursuit of knowledge. The Voyager program is an American scientific program that launched 2 interstellar probes, Voyager 1 and Voyager 2, in 1977. These probes have been exploring the outer reaches of our solar system and beyond for over 40 years, making them the farthest human-made objects from Earth. Originally designed to study the giant planets Jupiter and Saturn, the Voyagers took advantage of a rare planetary alignment that allowed them to slingshot past these planets and several of their moons, reaping a windfall of scientific data. They also became the first spacecraft to explore Uranus and Neptune, providing us with our first close-up views of these distant worlds. In addition to their planetary studies, the Voyagers have made significant contributions to our understanding of the heliosphere, the bubble of charged particles ejected by the sun that surrounds our solar system. In 2012, Voyager 1 became the first spacecraft to enter interstellar space, the region beyond the heliosphere. Voyager 2 followed suit in 2018. The Voyagers carry a golden record, a phonograph record containing a variety of sounds and images from Earth that is intended for any extraterrestrial intelligence that might encounter it. The record includes greetings in multiple languages, a variety of natural sounds such as thunder and whale calls, and music from different cultures. The Voyagers are still operational and continue to send data back to Earth, providing us with valuable information about the interstellar environment. They are a testament to human ingenuity and our enduring curiosity about the universe. Here are some of the key achievements of the Voyager program. Provided the first close-up images of the 4 giant outer planets, Jupiter, Saturn, Uranus, and Neptune. Discovered several new moons of these planets, including volcanic Io, the largest moon in the solar system. Revealed the complex structure of Saturn's rings. Studied the atmospheres of the giant planets and their moons, measured the solar wind and magnetic fields out to the edge of the solar system, provided the first direct evidence of the existence of the heliosphere, became the first spacecraft to enter interstellar space. The Voyager program is a remarkable achievement in space exploration. The Voyagers have taught us a great deal about our solar system and the universe beyond, and they continue to inspire us with their ongoing journey. This communication issue with Voyager 1 is more than just a technical glitch, it's a wake-up call. As our probes venture further into the cosmic unknown, we must prepare for such challenges. The resolution of this issue will not only ensure Voyager 1's continued journey, but also pave the way for future space missions. Here are some additional interesting tidbits about the Voyager space probes. Old school tech, big results. Voyager 1 and 2 launched in 1977, meaning they predate the smartphones we carry today. Each probe has about 3 million times less memory than a typical smartphone and transmits data at speeds 38,000 times slower than a 5G connection. Despite these limitations, they've returned a treasure trove of scientific data. Farewell song and cosmic sounds. The golden record carries not just images and scientific information, but also sounds. It includes a collection of natural sounds like thunder and whale calls, greetings in multiple languages, and music from various cultures, including works by Bach, Beethoven, and Chuck Berry. It's a kind of time capsule conveying the diversity of human experience. Space-age champions. As of 2024, Voyager 1 holds the record for the farthest human-made object from Earth, at a staggering 14.6 billion miles, 23.5 billion kilometers away. Both Voyager 1 and 2 are still operational and sending data back to Earth, making them the longest-running spacecraft missions in history. Saying goodbye, entering the unknown. In 2012, Voyager 1 crossed a significant threshold, the heliopause, the boundary where the sun's influence ends and interstellar space begins. This made it the first human-made object to enter interstellar space. Voyager 2 followed suit in 2018. Both probes continue their journey into the unknown, venturing deeper into the interstellar medium. Future uncertain, legacy enduring. The Voyagers are powered by radioisotope thermoelectric generators, RTGs, that convert heat from the natural decay of plutonium into electricity. Though the RTGs are expected to run out of power sometime in the 2030s, the Voyager spacecraft will continue to hurtle through interstellar space for millennia to come. They serve as a lasting testament to human curiosity and our desire to explore the cosmos. We are learning from Voyager 1. We are adapting, evolving. This distant spacecraft, a relic of the late 70s, is teaching us about resilience, about perseverance. It's a lesson we will carry into the future as we continue to push the boundaries of space exploration. There are actually no future Voyager programs planned. The Voyager 1 and 2 missions were launched in 1977 and were designed as flyby missions for the outer planets. Their incredible longevity and ongoing data collection are a huge bonus, but NASA isn't planning any new missions directly following in their footsteps. Space exploration continues to move forward, though. Here are some noteworthy efforts. New Frontiers program. This ongoing NASA program focuses on exploring the farthest reaches of our solar system. Its missions include New Horizons, which flew by Pluto in 2015, and the upcoming mission to Kuiper Belt object Ultima Thule, planned for 2029. Interstellar Probe. This is a proposed NASA mission concept for a spacecraft that would travel even farther than Voyager, potentially reaching the interstellar medium within 50 years. It's still in the early stages of development, but it shows there's continued interest in exploring beyond our solar system. Even though there aren't direct Voyager sequels, the original Voyagers continue to be ambassadors for humanity, venturing into the vast unknown and inspiring us to keep exploring the universe. So, will Voyager 1's voice be restored? Only time will tell. But one thing is certain, we will never stop listening. The universe is vast and full of mysteries, and Voyager 1, despite its silence, continues to be a beacon of human curiosity and determination. Thanks for joining this exploration of the Voyager probes. If you enjoyed this galactic journey, smash that like button and subscribe to Sci Sips for more scientific adventures.
Alright Sci Sippers, before you go hurtling back into the real world after this epic scientific odyssey, I want to take a quick moment to chat. Building this channel, bringing you these videos, and exploring the wonders of science with all of you is a blast. But to keep the scientific adventure going strong, your help is essential. Liking this video lets YouTube know you enjoyed it, which helps the algorithm share it with more curious minds like yours. Subscribing to the channel ensures you never miss a future science bonanza and lets you know when we upload new content. But the real magic happens in the comments. Leaving a comment, whether it's a question you have, a mind-blown reaction, or even a suggestion for a future topic, is like rocket fuel for the channel. It helps us understand what excites you and allows us to create even better videos that cater to your scientific interests. So, smash that like button, subscribe for more, and leave a comment below, letting us know what you thought of this wild ride through science. Thanks for joining the Sci Sips fam, and until next time, stay curious.
In the grand tapestry of Earth's history, continents have danced, collided, and drifted, shaping the world as we know it. Yet, the dance is far from over. Ever dreamt of a whole new ocean, splitting a continent in two? Well, buckle up, because that's exactly what's happening in Africa right now. Deep within the heart of Africa, a new act in this planetary ballet is unfolding. A hidden scar runs for thousands of miles. This isn't just any crack in the Earth's crust. It's a brewing revolution, a titanic struggle that will reshape the face of our planet. We're talking about the birth of a whole new ocean. The African tectonic plates are on the move, tearing the continent apart. This isn't some distant doomsday scenario. It's a real-life geological thriller unfolding before our very eyes. The stage for this geological spectacle is the East African Rift System, a colossal tear in the Earth's crust stretching thousands of kilometers. At the heart of this phenomenon are the Nubian and Somalian plates, two of the Earth's colossal tectonic plates. These titanic land masses are slowly separating, driven apart by the convective currents deep within the Earth's mantle. This rift is gradually widening at the rate of approximately 0.2 of an inch per year, a seemingly minuscule amount, but over millions of years, the consequences are profound. Imagine a zipper slowly undoing, creating a yawning chasm. As these plates diverge, magma from the Earth's mantle rises to fill the void, solidifying into new crust and widening the rift. Over time, this process will transform the East African rift into a new ocean basin, forever reshaping the face of our planet. One area of particular interest is the Afar Triangle, a geological hotspot where the Nubian, Somali, and Arabian plates converge. This region is a crucible of tectonic activity, setting the stage for significant shifts in the Earth's crust. This process is not without its dramatic flourishes. Volcanoes erupt, adding new layers to the emerging crust, while seismic activities hint at the intense energies at play beneath the surface. Yet, this is not a solitary performance. This geological drama is part of a grander symphony of Earth's dynamic crust. It echoes the ancient song of the Tethys Ocean, which once nestled between the continents of Gondwana and Laurasia. The remnants of Tethys sinking into the Earth's mantle have created plumes that contribute to the formation of new geological features, like the Indian Ocean geoid low. To sum up, the formation of a new ocean in East Africa is an awe-inspiring demonstration of plate tectonics at work. The slow divergence of the Nubian and Somalian plates, the rise of magma filling the widening rift, and the geological activity in the Afar Triangle all contribute to this remarkable process. The formation of this new ocean is a marathon, not a sprint. Geologists estimate it'll take at least 5 to 10 million years for the Rift Valley to widen enough and the Red Sea Gulf of Aden to flood in. As the African plate splits, Eastern Africa, including parts of Ethiopia, Kenya, Somalia, and Tanzania, could become a whole new continent. Imagine a future map with East Africa separated from the mainland. The East African Rift Valley is a hotspot for volcanic activity. As the plates pull apart, molten rock rises to the surface, creating dramatic volcanoes, lava flows, and geothermal wonders. The new ocean could become a haven for unique marine life. Salt water from the Red Sea would flow in, creating a new ecosystem for marine creatures to thrive. The birth of this new ocean mirrors how the Red Sea and Gulf of Aden formed millions of years ago when the Arabian plate separated from Africa. It's a natural process, constantly reshaping our planet. Scientists are tracking the movement of the tectonic plates using high-precision GPS technology. This allows them to measure the speed of the Rift Valley's expansion and predict the future path of the new ocean. The East African Rift Valley is like a giant natural wound exposing Earth's mantle, the layer beneath the crust. Studying the rocks and minerals here helps scientists understand the formation of our planet. The formation of the Rift Valley and the eventual ocean could significantly impact the existing ecosystems in the region. Freshwater lakes, for instance, might turn saline, forcing some species to adapt or migrate. Imagine landlocked countries like Uganda and Zambia gaining coastlines. This could have major economic and political implications for these nations. This may lead to potential new trade routes and resource exploration. A new ocean could influence regional weather patterns. It might affect rainfall and temperatures in surrounding areas. Studying geological events that take millions of years comes with challenges. Scientists have to rely on indirect evidence and models. The East African Rift Valley isn't alone. Another famous rift valley from around the world is the Great Rift Valley that runs from the Dead Sea to Mozambique, offering clues about continental drift. Indeed, the Earth is not a static stage but a dynamic, ever-evolving planet. The birth of a new ocean is but one act in the ongoing saga of our planet's history, a testament to the ceaseless dance of continents. This tale of creation, etched in stone and magma, reminds us that even in the face of eons, the Earth is still alive, still changing, and still full of surprises. So, that's the incredible story of Africa's tectonic tale. Millions of years from now, a whole new ocean could be gracing the map, and a brand new continent might even emerge. This is just a taste of the mind-blowing science out there, and we've got plenty more Sci Sips to quench your thirst for knowledge. Want to stay sipping on the latest science news? Leave a like, subscribe to Sci Sips for more epic science adventures, and let me know in the comments below. What do you think the future holds for this new ocean?
Alright, Sci Sippers, before you go hurtling back into the real world after this epic scientific odyssey, I want to take a quick moment to chat. Building this channel, bringing you these videos, and exploring the wonders of science with all of you is a blast. But to keep the scientific adventure going strong, your help is essential. Liking this video lets YouTube know you enjoyed it, which helps the algorithm share it with more curious minds like yours. Subscribing to the channel ensures you never miss a future science bonanza and lets you know when we upload new content. But the real magic happens in the comments. Leaving a comment, whether it's a question you have, a mind-blown reaction, or even a suggestion for a future topic, is like rocket fuel for the channel. It helps us understand what excites you and allows us to create even better videos that cater to your scientific interests. So, smash that like button, subscribe for more, and leave a comment below, letting us know what you thought of this wild ride through science. Thanks for joining the Sci Sips fam, and until next time, stay curious.
Picture this. It's 700 BC, and ancient humans are using a simple magnifying glass to harness the sun's energy, igniting a spark that would kindle centuries of innovation. In the hands of these early innovators, sunlight became a tool, a weapon, a means to ignite the fires of progress. Legend has it that Archimedes even used a solar death ray, focusing sunlight to set invading ships ablaze. Fast forward a few centuries and we find the Romans, masters at the art of engineering, using solar energy in a different way. They constructed sunrooms, capturing the sun's warmth to heat their homes and cultivate exotic plants. From the ancients to the Romans, the sun has been a source of power and fascination, but this was just the beginning. Fast forward to 1839, when a young French physicist named Edmond Becquerel made a groundbreaking discovery. In the hallowed halls of France's Musée de l'Homme, Becquerel was experimenting with an electrolytic cell made up of two metal electrodes placed in a conducting solution. It was there that he observed an increase in voltage when exposed to light. This was the birth of the photovoltaic cell, a device capable of converting sunlight into electrical energy, a concept as revolutionary as it was elegant. Imagine for a moment the audacity of such an idea. The sun, that great celestial furnace, not just warming our planet, but capable of powering it too. Becquerel's discovery was an early beacon in the field of photovoltaics, a term derived from the Greek word for light, phos, and volt, the unit of electromotive force. The photovoltaic effect, as it came to be known, was a phenomenon that promised a new era of energy generation. Yet, it wasn't until over a century later, in the mid-20th century, that this technology was harnessed effectively for practical use. The significance of Becquerel's work, however, cannot be overstated. It was a defining moment in the history of energy, a stepping stone towards a future where our power could be drawn directly from the boundless energy of the sun. Becquerel's invention was a game-changer, setting the stage for a solar revolution. As the 20th century dawned, the race to harness the power of the sun was on. In the heart of this race, Bell Laboratories made a breakthrough in 1954. The creation of the first practical solar cell marked a pivotal point in the history of solar energy. This silicon-based cell converted sunlight into electricity at an efficiency of 6%, a modest but promising start. With the advent of the space age, solar energy found its first practical application. The Vanguard 1 satellite, launched in 1958, was powered by tiny 1-watt solar cells and transmitted data back to Earth for over 7 years.
This marked a turning point, proving the limitless potential of solar energy in the realm of space exploration. Throughout the 70s and 80s, the focus shifted towards improving efficiency and reducing costs. The oil crisis of the 70s highlighted the volatility of fossil fuels and the necessity for renewable alternatives. This spurred significant advancements in solar technology, with efficiency rates of solar cells reaching upwards of 20%. In the 90s, solar power began to blossom in the commercial sector. Germany and Japan, in particular, made considerable strides in integrating solar energy into their national grids. By the end of the decade, the global capacity of solar power had grown to over 1,000 megawatts. As the millennium drew to a close, advancements in thin film technology and concentrated solar power further pushed the boundaries of what was achievable with solar energy. These breakthroughs allowed for the harnessing of sunlight on a larger scale, making solar power a viable competitor in the global energy market. By the end of the 20th century, solar energy was no longer a novelty, but a viable and sustainable source of power. The sun, a celestial body that has been revered and worshipped since the dawn of mankind, had finally been harnessed to fuel our modern world. The 20th century marked the beginning of a new era, an era powered by the sun. Today, solar technology is advancing at an unprecedented rate. The sun, a colossal celestial entity, is no longer just a distant star, but a wellspring of boundless energy, harnessed by human ingenuity. Let's delve into the realm of modern solar technologies, where the fusion of science and innovation is continually redefining boundaries. Consider the strides made in efficiency. According to a recent study from the National Renewable Energy Laboratory, scientists have developed a photovoltaic cell with an efficiency of more than 40%. This leap in technology is akin to swapping a horse-drawn carriage for a hypercar, propelling us into a new era of solar energy utilization. Yet the sun's power isn't just confined to stationary structures, it's also fueling a revolution in transportation. A report from the International Energy Agency highlights the advent of solar-powered vehicles. From cars to drones and even planes, these vehicles are no longer just figments of science fiction. They are tangible realities, moving silently on highways and in the skies powered by the sun. But what happens when night falls or clouds gather? Fear not, for advancements in solar storage technology have seen significant breakthroughs. A study published in the journal Energy Storage reports the development of cutting-edge solar batteries. These devices can store solar energy for extended periods, ensuring a consistent power supply, irrespective of the whims of weather or the cycle of day and night. Solar technology is not merely an alternative energy source, it is a testament to human potential and our capacity to harness the elements. These advancements are pushing the boundaries of what is possible, taking us into a future where solar power is a cornerstone of global energy production. Perovskite solar cells are a revolutionary new technology with the potential to be cheaper and more efficient than traditional silicon solar cells. These cells are made from a special type of material called perovskite, which can be manufactured using solution-based processes, similar to how ink is printed. This makes them significantly cheaper to produce than traditional silicon cells. Additionally, perovskite solar cells have shown promise in achieving very high efficiencies, potentially exceeding the efficiency limit of silicon cells. Researchers are also developing hybrid solar cells that combine perovskite and silicon technologies. These tandem cells can potentially achieve even higher efficiencies than either perovskite or silicon cells alone. By utilizing the complementary light absorption properties of both materials, these tandem cells can capture a wider range of sunlight, leading to increased energy production. Bifacial solar panels are a new type of solar panel that can capture sunlight from both sides of the panel. This is achieved by using a transparent backsheet that allows sunlight to pass through and be absorbed by the solar cells on the back of the panel. Bifacial panels can be particularly beneficial in applications where there is reflective light available from the ground or other surfaces, such as on rooftops or in solar carports. Solar energy is going to be a vital tool for any future space exploration and colonization endeavors. Here's how. Powering deep space missions. Lightweight and flexible solar panels. Current, rigid silicon panels might be bulky for spacecraft. Future advancements in perovskite cells or even organic solar cells could lead to lighter, more flexible panels that can conform to the curves of spaceships, maximizing sun exposure. Higher efficiency. As efficiencies of perovskite silicon tandem cells and other technologies improve, they'll generate more power from the same amount of sunlight, crucial for missions venturing further from the sun where sunlight is weaker. Self-sustaining habitats on other planets, deployable solar arrays. Imagine rapidly unfolding solar arrays on the Martian surface, providing power for habitats and research stations. Advancements in automation and self-assembly could make this a reality. Dust. Mitigation. Martian dust storms can coat solar panels, reducing efficiency. Technologies like self-cleaning surfaces or even vibrating panels to dislodge dust are being explored. Solar plus storage. Since sunlight on other planets isn't constant, think Martian nights. Combining solar power with energy storage solutions like advanced batteries will be crucial for a continuous energy supply. Space-based solar power, beaming power. Back to Earth. A far future concept involves gigantic solar arrays orbiting Earth, converting sunlight to energy and beaming it down wirelessly using microwaves. This could supplement Earth-based energy needs. However, technological hurdles and potential safety concerns need to be addressed. While there are challenges, solar energy research is constantly evolving. These advancements promise to play a key role in powering our future journeys into the cosmos. Solar energy has come a long way since those early days of magnifying glasses and sunrooms. From the ancient Greeks utilizing sunlight to ignite flames during warfare, to the Romans using sunrooms for horticulture, our journey with solar energy has been a testament to human ingenuity. The birth of the photovoltaic cell in the 19th century marked a pivotal turn, transforming passive solar power into an active, harnessable force. Advancements in the 20th century further refined these technologies, leading us to today's efficient solar panels and photovoltaic systems. These modern marvels are a culmination of centuries of exploration, invention, and refinement. As we look to the future, one thing is clear: the sun will continue to rise, and with it, so too will our ability to harness its incredible power. What other renewable energy sources would you like to see explored next? Leave a comment below, and subscribe to Sci Sips for future dives into science.
Alright Sci Sippers, before you go hurtling back into the real world after this epic scientific odyssey, I want to take a quick moment to chat. Building this channel, bringing you these videos, and exploring the wonders of science with all of you is a blast. But to keep the scientific adventure going strong, your help is essential. Liking this video lets YouTube know you enjoyed it, which helps the algorithm share it with more curious minds like yours. Subscribing to the channel ensures you never miss a future science bonanza and lets you know when we upload new content. But the real magic happens in the comments. Leaving a comment, whether it's a question you have, a mind-blown reaction, or even a suggestion for a future topic, is like rocket fuel for the channel. It helps us understand what excites you and allows us to create even better videos that cater to your scientific interests. So, smash that like button, subscribe for more, and leave a comment below, letting us know what you thought of this wild ride through science. Thanks for joining the Sci Sips fam, and until next time, stay curious.
Dive with us into the vortex of a groundbreaking experiment that has managed to replicate the rotation of black holes using a superfluid helium vortex. This experiment, detailed in the esteemed journal Nature, has been a revelation, showcasing near-frictionless dynamics eerily similar to black hole rotation. The team at the University of Nottingham used superfluid helium, a peculiar state of matter that behaves like a fluid with zero viscosity. This allowed for the observation of surface waves within the vortex, an uncanny replication of celestial vortices. This endeavour, though complex, isn't just about black holes. It's about bridging the gap between general relativity and quantum mechanics, two pillars of modern physics that have been notoriously difficult to reconcile. The experiment offers a tangible way to probe the quantum nature of black holes, opening a new pathway to unite these two disparate branches of physics. How does this experiment work? The core of the operation lies in the behavior of the superfluid helium vortex. As it rotates, the superfluid generates quantized vortices, miniature tornadoes of sorts, that mimic the gravitational conditions near rotating black holes. These vortices, akin to miniature black holes, exhibit surface waves that mirror the behavior of celestial vortices. Black holes are some of the most fascinating and mysterious objects in the universe. They are regions in space-time where gravity is so incredibly strong that nothing, not even light, can escape their grasp. Here's a breakdown of what we know about black holes: super strong gravity. Imagine squeezing a giant star several times its size into a tiny point. That's the immense density that gives black holes their powerful gravity. Event horizon, the boundary around a black hole where the escape velocity, the speed needed to escape, exceeds the speed of light, is called the event horizon. Once something crosses this point, there's no turning back. Formation. Black holes are born from the death of massive stars. When a star runs out of fuel, its core can collapse in on itself under its own weight. If the core is more than about 3 times the mass of our Sun, the collapse continues unabated, forming a black hole. There's another theory for supermassive black holes, which are much larger, but their formation process is not fully understood. What we can't see directly. Since light can't escape a black hole, we can't directly observe them, but we can detect their presence by the influence they have on surrounding matter. For instance, material swirling around a black hole can heat up and emit bright light before falling in, creating a signature that astronomers can use to identify them. Understanding black holes. Scientists are still unraveling the mysteries of black holes. There are many unanswered questions about what happens beyond the event horizon and how black holes interact with the universe around them. The implications of this experiment and its findings are vast for the field of black hole research. It paves the way for a deeper understanding of these cosmic enigmas. Furthermore, it has the potential to revolutionize other fields beyond astrophysics, such as superconductivity and technology development. The global market for quantum physics research is expected to flourish, fueled by groundbreaking experiments like this one. Here are 5 famous sci-fi movies that revolve around the topic of black holes. Interstellar, 2014, directed by Christopher Nolan. This movie explores the concept of a wormhole near a supermassive black hole as a means of interstellar travel. The visual depiction of the black hole Gargantua and its intense gravitational effects was lauded for its scientific accuracy. Event Horizon, 1997. This horror/sci-fi film follows a crew investigating the reappearance of an experimental spacecraft that was designed to create an artificial black hole as a means of faster-than-light travel. The movie explores the terrifying consequences of tampering with such powerful cosmic forces. The Black Hole, 1979. One of the earlier mainstream movies to feature a black hole. This Disney film follows a crew of space explorers who encounter a lost ship trapped in the gravitational pull of a massive black hole. Star Trek 2009. In this reboot of the Star Trek franchise, the villain Nero emerges from a black hole and creates an alternate reality, setting up the new timeline for the rebooted movies. Lost in Space, 1998. While not the central focus, this adaptation of the 1960s TV series features a pivotal scene where the Robinson family's spacecraft becomes trapped in the gravitational pull of a newly formed black hole. These movies have used black holes as a narrative device, exploring the mind-bending physics, potential for space exploration, and existential dangers associated with these cosmic phenomena. While it is not possible to create a full-scale black hole in the lab, scientists have been able to simulate certain aspects and dynamics of black holes using various experimental setups and techniques. Here are some ways researchers have aimed to study black hole physics in the laboratory. Analog black holes. These are systems that can mimic some properties of black holes by using materials that allow the formation of event horizons for perturbations or waves. For example, experiments have been done with fluids, ultra-cold atoms, or non-linear optical systems to create effective event horizons and study Hawking radiation analogues. Quantum simulation. By controlling and manipulating quantum systems like ultra-cold atoms or trapped ions, researchers can create systems that may exhibit dynamics similar to those found near the event horizon of a black hole. These quantum simulators allow testing theories about the extreme gravity environments near black holes, Bose-Einstein condensates. These ultra-cold clouds of atoms can be used to simulate aspects of curved spacetime and gravitational fields. By manipulating the condensates, scientists have observed phenomena akin to frame dragging and ergo regions around rotating black holes. Tabletop experiments, simple setups using materials like silicon, light or fluids, have been used to mimic certain characteristics of black holes, such as the bending of light or the formation of vortices that resemble the dragging of space-time. While these experiments cannot reproduce the full complexity of astrophysical black holes, they provide valuable insights into testing theories of gravity, quantum mechanics and thermodynamics in regimes that are difficult to probe directly through observations. Here are 3 mind-boggling facts about black holes. Spaghettification. If you were to fall into a black hole feet first, the difference in gravitational force between your feet and your head would be so extreme that you would literally be stretched out into a long, thin strand of molecules, like spaghetti. This process is known as spaghettification, and it would happen before you even reached the event horizon of the black hole. Time dilation. Due to the intense gravitational force of a black hole, time itself would appear to slow down the closer you get to the event horizon. From the perspective of an outside observer, if you were to approach the event horizon, you would appear to move more and more slowly until you seemed to freeze at the horizon itself, never quite crossing it. Holographic principle. According to the holographic principle, all the information contained within a black hole's event horizon is effectively encoded on the 2-dimensional surface of the horizon itself. This means that the 3-dimensional world we perceive may be effectively holographic, with all the information describing a region of space being encoded on its 2-dimensional boundary. This mind-bending concept challenges our fundamental understanding of how information and dimensions work in the universe. These facts illustrate the extreme and bizarre consequences of the immense gravitational forces present in black holes, which push our understanding of physics and reality to the limits. As we venture deeper into the quantum realm, the secrets of the universe reveal themselves in the most unexpected ways. So, as we stand on the precipice of this new era in black hole research, remember this. Even in the depths of a laboratory, we can touch the stars. The universe, in all its mystery and grandeur, is within our grasp. Thanks for watching this episode of Sci Sips. Do you have any lingering questions? Leave a comment below and hit that subscribe button to find out in the next video. Remember, don't let your thirst for knowledge go dry. Smash that like button and subscribe to Sci Sips for more mind-bending science content.